Let's get started. So our next session is done by Alex Morley here. Alex works for Babylon. He's an engineering manager, but maybe more importantly, he's going to talk to us about how to work with FHIR at scale using event-based event-based processing, basically. So kick it off. Oh, I've got one more thing to say. Maybe you've seen this in the other sessions, but after his talk, I'll be handing you the mic if you want to pose a question, so the people at home can hear your question as well. So if you want to pose a question, just show your hands, and I'll be chasing you down. All right, take it off.
Should I start again? Yeah. Cool, sorry about that. So I'm going to talk to you today about some problems that Babylon faced and overcome the last few years, and some of the innovations that we felt have helped us to overcome those problems. So I'm going to start off with a story, and then we'll talk about some of the tech stuff that's potentially more interesting. So long story short, started as a small company, small number of products and services. They needed to share information with one another, all good. They just ask each other for that information. Then we had lots of products and lots of services, and it became a bit of a mess. So we tried to simplify that communication by creating a central data access point, and also kind of centralizing data storage and data ownership. And that didn't work out too well for us. And so we changed to this new model of democratizing data across the company, and also democratizing the kind of storage, but keeping the kind of centralized access pattern. And so how we went from that kind of third circle to the fourth circle is what I'm going to focus on today. If I can get to the next slide. So just to go over that journey in a little bit more detail, we might have had something, originally we had a patient app, and that enables our patient to ask, questions about themselves, enter information about themselves. And to do that, it talks to the patient profile service. We have another app, the clinical portal, that our doctors look at. And that's where they book in consultations and can see their own consultations. But it doesn't work that those verticals can be neatly separated, because patients need to know what time their appointments start. And doctors need to know about for example, how old the patient they're going to see is. And that's kind of okay. We can kind of draw some lines between all of these things, and it didn't really matter. When we started adding more things, so we have a triage service that is going to give our patients some information about whether they need to see a doctor, but we also want the clinicians to see the results of those triages. And maybe we have a lab test service that's going to get some results for lab tests for us. And again, both the patients and doctors need to know this. And also the lab test service needs to know information about the patient, because they need to know how old they are, so they need to know what tests to run. And you can see basically it ends up being something like this. Why was this not great? So every time we draw a line between these things, we're adding new APIs or integrating with new APIs. We're also coupling services together, so that anytime one service changes, we have to change another one or 4 other ones. And we're also going to get inconsistency in the way data is represented across all our APIs. So end up being like slow development, we have poor performance, uptime, because anytime anything goes wrong, everything goes wrong. And what ends up happening is these different services end up storing their own copies of the same data. And so patients have to enter the same data in more than one place, depending on what part of Babylon's product they're using. Clinicians can't see all the data they need to, et cetera, et cetera. So simple solution. We know we want to use a unified language for talking about all the data that we have at Babylon, and FHIR was the obvious choice for that. And we know we don't want to have all of our services talking to each other about everything. So let's say, okay, all that anyone has to do to get all of our data about our patient is talk to our FHIR server. So this is our unified view of a patient in one place. This is going to be great. there's quite a lot of excitement about this, and it did solve some problems. So we now only have one API to integrate with for all of our data about patients. We've somewhat solved type coupling, like now we're only coupled with one other service for each of these services. And we shouldn't have data drift or inconsistency because we're using a centralized data store. I'm just going to go, before I talk about the problems with this, a lot of what FHIR is designed to do is to enable interoperability between external systems that work entirely independently. What I'm talking about here is systems built by folks who work 2 desks over and are actually working together to achieve a common goal. So they are somewhat independent, but they don't need all of the overhead for independence between external systems. So, and the other thing to notice is that we have an existing system. This isn't something we can build from scratch. So actually what everyone needed to do is translate all their existing data, how they'd modeled it in their services to start with, to FHIR in order to make sure it's written to the central store. And every time they add new features, they need to keep doing this. So we didn't really solve our slow development problem. And while now everything only depends on one service is great, but it makes that one service a really big single point of failure, especially because everyone's coupled to the same one. As the data team that has to look after that service, it's also very stressful. Whenever anything goes wrong, you have to recover very, very quickly. Otherwise, lots of things are broken. And in terms of data drift and consistency, we got some way into solving that problem. But in practice, teams like to have their own domain model that they then replicate to FHIR, which means it remained possible to store weight in 2 different formats in this store, and profiles weren't really enough to solve this problem for us. There's another talk later on from someone about, we could talk a bit more about why that's not enough in this kind of internal use case. And we still also didn't get good performance because lots of read and writes to the same database is pretty hard to scale performantly. So the simple solution actually ended up being, this FHIR server ended up becoming a bottleneck for us and really hard for the data team to manage. We had some complaints. Why do I have to keep re-entering my information in different places? Patients, clinicians still couldn't see all the data patients given to Babylon. Product developers weren't that into FHIR. Why do we have to write all this crazy amount of information? We just want to save a weight value. And they didn't have time to do this while building existing features. Data engineers were, having become this kind of bottleneck, were being asked questions about data that they didn't understand. They're data engineers, they don't understand all of the product domains that we have at Babylon. And trying to support a database that serves all the reason rights of the company is really difficult. And the analysts didn't really ever get used to FHIR either. It's really nested. It's not, wasn't super nice for how they used to do things. And not all the data that ended up in our FHIR server could easily end up in our analytics tooling without, in a timely fashion. So yeah, that's my candid moment. No one was super happy and it kind of sucked. It also kind of sucked because we were really, really excited about this and we really thought it was going to solve all of our problems, maybe naively. So we wanted to design a solution that doesn't couple services unnecessarily, is kind of easier and lightweight for developers while still having this interoperability. And really, really importantly, what I've said here is using consistent domain model. What I really mean is using a unified modeling language. So talking about data in the same way across the company. We wanted to democratize the ownership so that the people that know about the data are the people that are kind of owning it and having the expertise on it. It needs to be performant and reliable. It needs to be extensible, scalable in both sense of the word, both in terms of performance, but also in terms of growing business and future-proof. So what we came up with, I'm going to go through this very quickly. Not a lot of it is going to make sense because I'm going to go into each bit. So bear with me for a sec. So the solution that we came up with is that services publish updates, all updates to data as DFHIR data streams. Come on to what DFHIR is in a sec. We have something that converts DFHIR into FHIR, and then we materialize a read and search optimized data cache, you might call it, that contains both our DFHIR and FHIR. And so this kind of long box of the model is in our case, Kafka is our streaming platform. If anyone isn't like super familiar with why streaming is great or why it's useful, I really, really encourage going to this link. I'll share it on Hoover afterwards as well, called Gently Down the Stream, which is a fantastic comic using otters to explain why streaming is really helpful. And also we can materialize other views from these data streams to use for other use cases. Let's say we maybe don't want to put every single heart rate recording that we're collecting from millions of devices into the same data store that we're using to serve our clinical portal. We can easily materialize other views from these streams, and we can also build some kind of real-time alerting or AI applications off these streams as well. So first thing I'll talk about is DFHIR and FHIR. So this is one of those problems that's like very specific to using FHIR internally and not using FHIR externally. So this is a slightly contrived example of a conversation that's kind of partly between a service called Patient Metrics and our data service, and partly between the people that work on the Patient Metrics team and our team. So we just got this new value. This is the patient. This is the weight. Thought you might want to know. And they're like, oh, well, what does that mean? What units are you using? What is weight? Do you mean this code? They're saying kilograms, the same as like literally every other way I've ever sent you. And sure, that is the code, but it's just, for us, we talk about it as weight because, you know, that's what it is. Oh, actually, we've got another one, same patient, different weight. Oh, and we get the same question back because it doesn't make sense. So how DFHIR works is that these patient metrics team are actually going to give the data service a template that it can use to interpret everything that they're about to say. And so it's a bit small on the screen, but the template essentially has two parts. It has the parameters part, so that's the patient ID and weight. And then it has what we call here hydrated part, which is essentially the FHIR resource, and then some indication about where those parameters should be put inside the FHIR resource. So on this one, you can see that the patient ID is going to be interpolated into the reference patient/patient ID. And for the weight value, it's going to be put in the value quantity value bit. But everything else is pre-populated. We've already pre-populated the unit, the systems, the codes. And it actually does a bunch more clever stuff than just basic interpolation, but not going to go into that now. So now service can just say, hey, we've got this new value, thought you might want to know. And our data service can understand it really easily. So just go through those terms a little bit. What is DFHIR? So DFHIR stands for dehydrated FHIR. That's the parameters bit. But all it really means is something that can be rehydrated into FHIR using a DFHIR template. What's a DFHIR template? This is our DFHIR template. And the point is that we didn't want to force everyone and everyone's service to have to understand every part of FHIR and build models and everything every time they want to send any piece of data to us. We just wanted to make sure that all of their data is available in a FHIR format if required. And there are some other cool things too. So one of the main things as that covers, developer experience is king, because the easier we make this, the more people do it, the better coverage of all the data we have across our business. We can easily apply constraints within our data model. So obviously we can do this with FHIR profiles, but what we have with DFHIR actually is we have this to an extent where creating an invalid FHIR resource becomes almost impossible, because if you go back to one of these templates, if your patient ID is an integer and your weight is a float, your resource is going to be valid, because when we've created this template, we've already done the checks that this template can only produce valid values given those parameters. FHIR profiles come for free. With that template, we can easily generate all the structure definitions and everything that we need. And from those structure definitions, we can also generate some other things too, which I'll go into later. DFHIR FHIR is always reversible. DFHIR is much flatter, which makes our analysts happy. And because these constraints are no longer primarily enforced at the FHIR server level, they're enforced when you're writing the data, it's much easier for us to allow domain owners to really own the data. Yeah, a couple of related talks about this. Greg talking over all the details of dehydrated FHIR tomorrow. And the library that we use to build Hydrant, which is the thing that does our hydration and dehydration, uses a different library, another FHIR library called lip, which Hugh is going to be talking about later today. So next bit is domain ownership. So what we really needed to make sure that data wasn't duplicated across the organization is that there's always a team that owns every type of data. So everything to do with triages goes through the triage service and ends up in this triage stream. Ditto with patient profiles is going to end up in this patient stream. And now that we're not going to touch the data until step 2, remember now, so all the validation needs to be done before we write the stream. So the streams are kind of the canonical source of the data. And how does this work? Yes, it's all about making sure that the folks that understand the data own its full life cycle from modeling to operational to analytics, the whole shebang. And this has 2 implications for us as a data platform team. So one of them is, how do we ensure that all of the data is actually properly owned by someone in the business? Where do we draw lines between domains? And then how do we make the burden of domain ownership as low as possible? So remember, one of our original complaints was people didn't want to have to understand and write FHIR and couple their services to this other server. But how can we keep this as low as possible? So first thing, how do we draw lines between domains? We use FHIR for this, not in a perfect way, but in a what makes sense for our business way. So we think, okay, does a FHIR resource make sense as a domain? Something like patient coverage, consultation appointment. Quite often it does for those ones. Sometimes it doesn't. So for something that I would say it doesn't, would be something like an encounter, because having a team that owns all encounters, when an encounter can be something from looking at your phone to going to the GP to going to the hospital, doesn't make sense. They're very different from a business point of view. So maybe we go a level down, like, is there an existing FHIR profile that makes sense? So vital signs, social history, conditions. So that'll be conditions using observation resource, not the condition resource. And if really that doesn't make sense, okay, then we'll make an exception. So when we built a whole bunch of stuff around COVID, when that started, we used COVID as a domain. We have an advisor service that does a very specific set of things. And because we generate profiles for everything anyway, there is still a profile that matches this. It's just not one of the existing ones. The other part here was, how do we make the burden of domain ownership as low as possible? And the data architecture is what enables this. And the main reason that it does is because we're architecturally decoupling data publishing from data consumption. So all a domain owner has to think about is publishing their data. They don't have to worry about how it's going to be consumed. And who worries about make sure the data is easy to consume? That's us as a data platform team. Because we're now free from the responsibility about kind of accepting the data, making sure that all happens in a timely fashion, we can focus on building the tooling to make the data easy to consume for all use cases. And one of the things that we've done there is created an application-friendly API. So FHIR API is great for interoperability, but when you're just trying to build an application, there can be too much there. There's stuff there that you don't need to build an application. Similar to why we use DFHIR internally, we don't need everything that FHIR gives us when we're just making requests between our patient app and our backend services. So what we'll notice is we use GraphQL. Come to why we don't use exactly the FHIR GraphQL yet, but we have an application-friendly API, so we use GraphQL for this. These GraphQL, there's an example query here. So this would be getting all the encounters, all the observations for all the encounters on a patient filtered by encounters that are finished and by this practitioner. The schemas for all of these are automatically generated. So as soon as you create a DFHIR template, it's automatically going to generate all your structure definitions. And from your structure definitions, we can generate all your GraphQL schemas. So again, all domain owner has to worry about is thinking about this DFHIR model, and then everything else is handled for them. It's handled by our platform. Okay, there is a FHIR spec for GraphQL. Why didn't we use it? Sad face, it is sad. And long term, I think we like to move a little bit closer. The short answer is developer experience. Long answer is we needed a few things that weren't there in the GraphQL spec at the time. So first is first-class extension support. So we expose extensions as if they're any other field, because there's lots of stuff that you need in an app that is always going to be extension in a FHIR resource, and it's more convenient to use when it's there. We make sure all lists are connections, which is useful for a lot of things. There's quite a nice little filtering syntax there. And I think probably one of the key things is that you can do graph traversal. So reference fields resolve directly to the reference resource rather than to a reference type. Also, we have a bunch more error types than are supported in the other one. And so finally, we have AI agents and real-time stream processing. So the cool thing about writing to a stream isn't now just for domains that stream is going to end up in a system that can be read by everyone and also can be interoperable. It also means that anyone else can react to any event that happens in the company. So some examples like this might be something like really trivial, like patient X's weight was updated, let's update their BMI. But we can build on that to go like, okay, actually there's now going to be a BMI stream. So now that the BMI is updated, let's update their risk assessment for complications from type 2 diabetes. Or now that there's a new risk assessment that requires action, let's notify the patient to reach out to the care team, and let's also notify the care team to reach out to the patient. I've come to this well ahead of time, so we're going to have a whole bunch of time for questions, and also maybe I'll go through that streaming comic because I love it and I think everyone should see it. So this is a summary of the thing. So we're going from domain services publish their updates as DFHIR data streams. We have a process that converts DFHIR to FHIR. We materialize a read and search optimized data cache that has a GraphQL gateway in front of it. We have the ability to materialize other views for specialized for other use cases. We have AI agents. And I thought I'd updated this slide. Oh yeah. Yeah, and so we do that using making sure we have nice domain ownership, good data architecture, application-friendly APIs. And finally, when we actually need a FHIR server for some of our clients, we can just put it on top of all of this. Writes will end up going to streams, reads will end up coming from our GraphQL gateway, and we still have the FHIR server for interoperability with other partners, just not internally. I have to put this in for my comms team. We're hiring. Thank you very much.
Right, Alex, I have two questions coming in from Huva. Maybe we could start with them as we have time enough. The first one is, did you try and look at FHIR patch instead of dehydrated FHIR?
I don't know the answer to that question. I don't think we did. I have someone in the back who might give me a thumbs up or a thumbs down. Maybe. Helpful.
You sort of thought about it?
Yeah, sort of thought about it. Yeah.
So the answer is you didn't, more or less. Yeah, okay. Well, I can see how that might work. Well, second question, how do you maintain data consistently when multiple applications update the same value?
Yeah, so there are obviously, there's a bit of detail missing out from this diagram, which is that updates to the triage stream can happen in two ways. So you can either just write directly to the triage stream, and what you do here is dependent on what the domain team wants. You can either, if you're the patient profile service and for some reason you've been given a piece of information about triage, you in general shouldn't write that data to the triage stream. You in fact, that data should never come to you. It should just go to the triage service. But you would write it to the triage service, and then triage service would be responsible for writing it to the stream. And the triage service will still and can maintain its own domain-oriented data store. So it doesn't use FHIR, uses everything that it needs to do, and it can handle any consistency issues on its own. So that's the responsibility of domain teams, as it would have been before.
Right. So you're saying in a distributed situation, each service has its own data that it keeps consistent. So there's nothing shared that you need to keep consistent, right?
Yes, exactly.
Okay, great. Question from Brian.
This is very cool. I appreciate this talk. As you have kind of, I saw you mentioned CQRS, you kind of have an eventually consistent system here. I'm wondering, and GraphQL is sometimes about like payload size. Like as far as developer goes, you still have to know human name and all the stuff, like how the schema is laid out, I'm assuming. I'm wondering, did you look at, or how do you connect kind of pushing new events on your event stream and working their way up to the app? And did you look at HTTP2 at all, or did you just go right to GraphQL?
So we went to GraphQL, well, primarily because it allows people to choose what data they get from the resources. In terms of this like eventual consistency, being able to push data to the app, it's something that we're actually working on actively at the moment, and we're using GraphQL subscriptions for, so WebSockets essentially.
Nikolai.
Thank you for the talk. The classical question for event streaming. So how do you handle schema changes?
Yeah, so sorry, I keep on waiting for the microphone to come back, even though I've got my own. So schema changes, so the important schema changes that in terms of being within our streams are the ones in DFHIR, not FHIR. So the way our DFHIR is encoded in streams is protobuf. We have a schema registry that looks after all those protobuf schemas, and we actually don't allow breaking changes in those DFHIR schemas at all. It turns out even not allowing, if you don't allow breaking changes in the DFHIR, you can still kind of get any FHIR that you want, which is quite a neat property. And then obviously making fields optional whenever you want, basically as a default, is useful. And then worst case, if you do need to make a breaking change, you make a new stream, and that has to be handled by consuming services.
I'll do two other questions from Huva, and then I'll get back to you there. Question: do the domain services persist application data and additionally send DFHIR messages? How do you ensure the data stays in sync?
Yeah, this is yes, they do. In general, it's kind of up to domains whether they want to keep their own copy of the data or not. Some cases are required to, some cases they're not. When they do, they're it's a slightly tricky problem. So imagine you have a transactional data store and you need to make sure that you are writing data to that transactional data store and to Kafka. And you have to make sure that regardless of what happens, that data either goes to both or to neither. And so the kind of classical problem to this kind of distributed, what we would call like a to-write problem, is I've forgotten the name for it now. Anyway, it's a thing that's not supported by Kafka. And so the way we do it is by instead using the outbox pattern. So when you write your data to your transactional data store, you write it to two tables at once. So you write it to your main data table and also to an outbox table. And then within the same pod, all our services run on Kubernetes. Within the same pod, we have a separate container that listens to events on the outbox table and publishes them to the stream. Yeah, and it does that consistently. So because the initial transaction of table and outbox table is consistent, and the second process is asynchronous, it means we can always maintain consistency there.
Next one. This was actually something that I'm wrestling with as well. So good question. Anyway, the next question. If a consumer calls a FHIR write API, how does the data get updated in the source systems after your FHIR data store is updated?
It doesn't. It gets updated in the source systems before the FHIR system. So writes to a FHIR server. And so this is, again, something we're working on actively at the moment. So if it write to a FHIR gateway will then be, we have a layer that will do a translation from that to be a write to any of the domain services. And then, yeah, eventually it'll get propagated back to the FHIR server.
Yeah, so it's not, there's not a single store you're distributing it to all the services, right? So there's no update after or before the
Yeah,
data.
so this searchable data cache, another way of putting it, this searchable data cache is not writable by anything other than consuming from these streams.
All right, I'll pose this third question and then move slowly to this direction. Do you have any particular problems with versioning and data migration while using FHIR templates?
Yes. I think we mainly have a problem with making it easy. It's never a problem that can't be solved. We have some neat stuff where, like, if you so in terms of migrations within the data cache is something that's fun, because you have search indexes there and you need to be able to make sure that when you change schemas, you also migrate potentially your index mappings when we're using Elasticsearch and things like that. So we've automated a whole bunch of that side. The other side, to making sure that like sometimes you might have to like upcast a whole stream or do something like that. I think it's quite a manual process and quite ad hoc. And so that's something that we're looking to build a bit more tooling around at the moment.
Sounds like an honest answer though. Yeah. All right, the question in the room.
Hey, how do you handle like data recovery when you have streaming data? Do you pause sort of the stream, do a recovery? Can you talk a little bit about how we've handled that?
So how do you mean by data recovery? So just in case this is relevant, the streams are all persistent streams. So they're not ephemeral.
Right. No, what I mean is, like, if there's however you're storing the data at the very end, I understand that's FHIR, right? Or is it?
So within the streams is FHIR.
Okay.
Yeah.
And then but how do you actually persist the data?
So the data is persisted in two places, right? It's in the domain services, gets published as FHIR, and then I say this is then persisted in a store as FHIR and FHIR. I would call that store a cache.
Okay.
Because although that's the only place where the FHIR is held, almost. We do have FHIR streams as well for things that need them, but although that's the only place the FHIR is held, because we can just replay the whole stream into that data store, to us, we treat it like a cache.
Okay.
Yeah.
I see. So basically you have, I guess your data recovery is really replaying the stream.
Exactly.
Okay.
Next question from the room.
Maybe a related question. I'm curious, when you bring a new app online and it needs to catch up to get all of the sort of available data, how does that work?
Yeah, so this is a new app that's consuming from that. It just catches up. It just works. So do you maintain your streams from all time? Yeah, so we do for all of our, we have some, for all of our FHIR streams, so all of our health data, we maintain them in all time. Oh, wow. We also, so we do have some streams that we don't do that for. So which mostly not health data, so like audit streams, things like that. But we still persist all of that data into S3, and we have a process where you can replay all the data from S3, so our cold storage essentially, back into a stream. And so if you do need to do that, then that's how you would do that. But
so it's conceivable if a new app came online like a few years from now, it could take a while to replay all the streams. Yeah, but I mean, worst case, I think the longest, and we have had apps come on a year after the data has been presented, worst case is takes a few hours. Obviously, it depends how well your app is written. If you're persisting it to a data store that's fast to write to, supports batching, all those kind of things. But
sometime when you're modeling your application, you find that there are some clinical data that can be mapped to FHIR, but some data that actually doesn't map to FHIR. And still, this data is very crucial for your apps to work, kind of workflows, state management, things like that. How are you handling that? Are you doing any custom resources in FHIR, for an example, between the organization Or what is your methodology in propagating this data across the system that need to consume it?
Yeah, so we had this as quite a big concern when we started off with this pattern. Run into it a lot less frequently than we'd have expected to. It tends to be that you can get that piece of information in somewhere, even if it's not perfect. And remember, because the point of that will not be for interoperability across systems, it's to make sure we just treat it in the same way as every other data. If we're using a basic resource full of extensions, that's okay. It still works with all of our tooling. And so that would be our kind of cop out for those kind of scenarios. Yeah, I forget the exact terminology, but there's like a basic resource that you can use to do that, and then you throw everything in extensions. And remember, because our GraphQL gateway has first-class support for extensions, so when you're consuming from it, you don't know that that's an extension. You don't, because you just know that that's a field. We take the extension bit out.
So you don't write like inherit resources from the domain, but you're doing it as extension, and you agree with the different services to consume the extensions.
Yeah, but it's only an extension in this searchable data cache, right, where it's FHIR, because in DFHIR, it's just whatever you want it to be, because it's just your parameters. And in the GraphQL gateway, we've got rid of the extension part as well. So it's hidden from most people for most use cases.
Okay, while I move in the room, question from Huva. Considering this is health data, do you do encryption? If yes, how?
Yes, we do encryption in some places and not in others. So all of our streaming systems have encryption. The difficult part with that is key rotation. So I'm not going to go into that, but that's the hard bit about encryption there. The encryption itself is fine. In the searchable data cache, we use essentially we use managed services for this provided by AWS, and we use their kind of native protections against these things. So what we can do is make sure that only certain services can read the values in plain, and other services read them as like masked or encrypted or hashed. But yeah, there are several layers of access control over that searchable data cache provided by AWS, rather than hand rolling our own encryption. Obviously, in transit and at rest, it's all encrypted anyway.
Curious about the data ownership piece and how natural that was. You know, you had a bunch of existing technology. Did you find yourself sort of press fitting back into like, okay, so we've already got this service, which profiles or resources should they own? Were there any really sticky bits? And I guess one maybe detailed question, is it true that if I look at any FHIR resource that shows up in the searchable data cache, I can find like, okay, yes, it definitely came from this DFHIR transform and was owned by this service? Like, is that, does that chain work backwards?
Yeah, so that second bit is true. Yeah, in terms of natural data ownership, it was a little bit painful at the very beginning. And got easier as time went on. Trying to think of some examples. So we had, in general, the kind of problem was that we had our services mostly organized around products rather than domains. But the shift towards domains anyway was kind of already happening separately within the business. We had a problem. We kind of had a problem that, like, if you're sunsetting a product and that product team has originally owned the domain, and how are you going to shift that across? So, but in the last kind of 6 months or so 18 months since we started this, that kind of problem has gone away. We know what domains we need. All of the domains we talk about are guided, except for a few exceptions, are guided by FHIR terminology, and it's actually made that quite a lot easier. For a start, we don't have to worry about naming stuff, because we go like, okay, FHIR calls it this, we don't mind if we think that's sensible or not, that's what we're going to call it, because then we're talking about the same thing as everyone else.
Gino.
Thanks, Eamon. Shifting gears for a second, for the GraphQL query side and everything, how have you dealt with modifier elements and modifier extensions? If someone doesn't request them in their GraphQL, or especially if they're promoted to first level support, you lose a lot of that tagging that's inherent in the structure.
Yeah, I heard you mention this yesterday, and I was thinking about it. So we've only hit it in a few cases where we've had to use modifier extensions. Obviously, we lean away from using them whenever possible. And our current solution is to throw an error if someone doesn't request a field that is a modifier extension, which is safe. It's not pretty, but it's safe. I think there might be something neater we can do later on with directives to move that error out of the, to kind of move that error up into the gateway layer, but we haven't looked at that seriously yet because we don't have enough cases that it's that important.
I have another question here from Huva. How do the services writing data pick the right DFHIR template they want to use?
They make them. So the services that write in the data, they do own their DFHIR templates. So there is still one person that has to think about, okay, how do we create this mapping? And that one person is someone from the domain team. We kind of, as a data team, we provide a bit of like consultation-like support. We have some tooling around creating this template. We have a UI that allows you to say, okay, here is what the kind of data I want to save. Let me pick from these different FHIR resources and do the mapping in the UI, which then creates the JSON template from the UI that I showed you earlier. Yeah, so that's one of the ways we make it easier. But yeah, again, it's the domain services doing that work. Domain teams.
Next one. Yep, that's good that you had some time left here. Eh? Are there any big data advantages or big data advantages, I don't know, to the cached FHIR data? How do you make the FHIR data available for a big data use case in addition to the transactional use case?
Yeah, so in general, this kind of goes to point 4 on the slide in terms of big data, is that if we have a specialized use case, then we can materialize specialized views using whatever database we want in order to do things like that. So one example might be just streaming all that data to Google BigQuery if we want to use it for that, and then let someone else handle it, or another managed service. So in general, that's how we do it. If we wouldn't try and put big data in our searchable data cache because that's not what it's for. And so we wouldn't put those streams in there.
Do you run an in-house FHIR server to handle DFHIR?
No, no. Essentially, we don't have a because we don't use a FHIR server internally. The way people access is mostly through this GraphQL gateway. In terms of handling DFHIR, there is a service that projects the DFHIR streams into this searchable data cache. But no. And so we don't, internally, we're not using any kind of FHIR operations as such. We're just using it as a modeling language.
Just a quick question with the converting from DFHIR to FHIR, are there any like terminology, like enforcement, like even something simple like patient gender is a required value set? Are you doing anything to like make sure the source systems are adhering to these policies that either FHIR has or you may have?
Yeah, so our practice with that is that we try and push as much of that validation into the DFHIR level so that it becomes difficult to construct invalid DFHIR. And we also have a lot of validation around the template itself. So we use some like property-based testing that shows that using this template, it should be impossible to put any values in DFHIR that create an invalid FHIR resource. And so that doesn't just do structural tests, but also conformance testing. So doing codes in the right value sets, like you said. Then we additionally, as we convert to FHIR, we additionally redo any conformance in case there might be something that our property testing has missed or something like that before it goes in the searchable data cache and it's marked. It does still get stored, but it's marked as invalid and marked as something we have to deal with at some point.
All right, thank you. Believe it or not, there's still more questions streaming in, but we're at time. The good thing about the Huva questions is though that, everyone can keep asking questions in here, and I hope you'll be able to answer a few of those after the session. So keep them coming if you're interested. And here we are going, I guess, to the next session. Thank you.
Awesome. Thanks, folks.